Hi students, today first I'll complete all the remaining subtopics from last session and then we'll start a new motion which is motion in a vertical direction. This is also a part of one-dimensional motion, but here the difference is that this direction has to be the vertical direction. So shall we start? One other very common kinematical expression is there, which is distance travelled in nth second, because in a number of numericals you will have to use this distance travelled in nth second, and every time it is not possible to derive the whole formula. So already one ready-made formula is there. So let us see how distance travelled can be calculated for nth second. If it is asking for nth second, then of course we have to consider the time span for motion to be n second. So now I am writing the distance travelled for n seconds of motion. What would be Sn? If you write, that will be equal to, this is distance travelled in n second, it will be equal to ut. Now in place of t you have to write n because time span is n here. So it will be un plus half a n square. This is distance travelled in n seconds. Now how can we get distance travelled in nth second? See, if in n second the particle has travelled this much distance, it is Sn. The distance is travelled in second n. And if we write distance travelled in Sn minus 1 second, and let it comes up to this. So what would be distance travelled in nth second? It will be this distance. Let this be denoted by delta s. Then delta s is the distance travelled in nth second. Now to write distance travelled in nth second, you cannot directly use the formula ut plus half at square, because as you see, in this part of journey we are not aware of what is its initial velocity. We have to calculate it. So directly we cannot write the formula, whereas for the entire part of course we must be knowing the initial velocity. For this part, as initial velocity is not known, so directly we cannot use the formula for delta s. We have to write Sn and then Sn minus 1 and then subtract Sn minus 1 from Sn. So the same way I am proceeding here. Next is Sn minus 1. It has to be written as u. Now the time for journey has become n minus 1. So this is n minus 1 plus half a and square of n minus 1. Now to get delta s, it will be Sn minus Sn minus 1. So this can be written as, if you substitute, that will be un plus half an square minus un minus 1 plus half a square of n minus 1, and on subtracting you will get u plus a by 2n minus 1. So this is distance travelled in nth second. Whenever it is asking for distance travelled in 5th second, in 6th second or any particular second, you can use this formula directly. Do remember, this is only valid only if acceleration is constant. Otherwise you have to proceed through the general derivation, that is a is equal to dv by dt and v is equal to ds by dt, which is applicable everywhere. Now I am taking some of the illustration to clarify all the concepts you have learned till now. The first illustration is, it is saying a car is moving at a rate of 18 km per hour, and when the brakes are applied, it comes to rest in a distance of 100 meter. What is retardation produced by the brakes? So here, since it is being stopped, so of course final velocity has to be 0. And what about the initial velocity? That is given 18 km per hour. So first convert it to meter per second. Do you know the conversion? This has to be multiplied with 5 by 18. Whenever a speed is given in kilometer per hour and has to be converted to meter per second, this would be multiplied with 5 by 18. So you will get this value as 5 meter per second. This is the value of u we obtained after conversion. Now distance travelled is given, that is equal to 100 meter. So which formula should we use? In this also students gets confused frequently which of the formula has to be used to solve a given particular problem. Now you have to check what quantities are given and what is to be calculated. So here as you can see, V, U and S are provided and you have to calculate A. So can you remember any of the formula in which these four are related? Yes, this is the third one which we had written. V square is equal to U square plus 2AS. Now if you substitute the values, this is 0 is equal to square of 5 which is 25 plus 2A into 100. If you calculate this value from here, A will be equal to 25 upon 200. Obviously one minus sign will be there and it is equal to minus 1 by 8, that is minus 0.125 meter per second square. The value has come as negative because it is retardation. So if it is asking for retardation, now again you have to remember in question, since it is asking for retardation itself, so there is no need to write this minus sign in your answer. But if it asks for acceleration, then you have to write with minus sign, and generally both options will be there in the question in your exam. So it will be plus and minus. If it is asking for retardation, just write without the sign, and if it is asking for acceleration, write with the sign. Will remember this? Okay, let us move. Now come to one more illustration is there. The velocity of an object is changing with time and relation is given by following equation, that is given v is equal to 2t plus 3t square. Calculate the position of object from the origin at t is equal to 2 seconds. We have to assume that particle is at origin at t is equal to 0. Okay, so we know the expression of v, that is v is equal to 2t plus 3t square. Since it is asking for position, so v can be written as ds by dt, that is equal to 2t plus 3t square. See, we are doing all these numericals assuming that already you know basic of the calculus, right? And since in your 11th and 12th class you must have learned the basic rules for integration and differentiation, so it can be directly applied here. Or you can write ds is equal to 2t plus 3t square. Now integrate. It is asking for time is equal to 2 seconds, so it has to be integrated within limits t is equal to 0 to t is equal to 2. And origin at t is equal to 0, the particle was at origin, so initial s is origin itself, 0 itself, and then we have to write value of s. What would be? Just integrate this, you will get 2 t square by 2, these two got cancelled, plus 3 t cube by 3, again these two got cancelled within the limits 0 to 2, and on solving that will be 4 plus 8 which is equal to 12 meter. So this is your answer, position at t is equal to 2 seconds. Come to the next question. This is third illustration. A particle starts moving from position of rest under a constant acceleration. If it travels a distance x in t second, what distance will it travel in next t second? Okay, so it is starting with 0. Initial velocity is 0. It is starting from rest, so initial velocity has to be 0 and acceleration is given constant. It is traveling a distance x in t second. So first let us calculate the acceleration. How can we write it? X is equal to u is given 0, so directly it will be half a t square. From here we got value of a is equal to 2x upon t square. Now let us consider that particle had started from this point and for t second it has travelled this much distance which is equal to x, and in next t second it is travelling a distance, let this be x dash. Time interval is same for both the journey. This is t and for next part also it is t. Can we write s is equal to ut plus half at square for this part of journey? No, we cannot write because initial velocity for this part is not provided. Of course, we can write for the whole journey because initial velocity for the whole journey as we know is 0. So let us write the formula for whole journey. That will be equal to, since distance travelled is x plus x dash, that is equal to u is given 0. So directly it can be written as half a. Now what is time span for this whole journey? That is equal to 2t. So square of that term, it will be 4t square. Now write expression of a from the above equation. That will come out as 1 by 2. In place of a, you have to write 2x upon t square into 4t square. These two got cancelled. 2 got cancelled. You got value of 4x. So x dash will be, which is the distance travelled in next t second, that will be 4x minus x is equal to 3x. This is the distance travelled in next t second. One more question is there. Two ends of a train moving with a constant acceleration passes a certain point with velocity u and v. Okay, so let this be that point, that particular point O, and a train which has a length L. Let us consider length of train be L. So it is passing the point O. When engine is passing this point O, it has velocity, the engine has velocity u, and when this part is the rear portion is passing the point, it has velocity v. Right? Do not think that at the same moment engine has velocity u and rear portion has velocity v. No, this is not possible. What I am saying is, when engine is crossing the point O, train has velocity u, and when rear portion is crossing the point, the train has velocity v. Of course, the entire train must be moving with the same velocity at any particular instant. This is not possible for a train to having different velocities for its different part, because otherwise the train will break. So what we are considering, that u is the velocity when engine is passing point O, and v is the velocity when the rear portion is passing the point O. Now if distance is travelled between these two moments is L, that of course has to be equal to length of the train. So we can calculate what should be the acceleration involved. How can we write it? V square is equal to u square plus 2al, because in travelling a distance L, train has acquired velocity v from u. So it can be written v square is equal to u square plus 2al. It is asking, when this middle portion is passing the point O, what will be its velocity? When this middle portion will pass the point O, this middle portion is at a distance L by 2 from the engine. So after traversing distance L by 2, when engine has crossed, after that the train will travel a distance L by 2, and then at that moment middle of the train will cross through the point O. So we have to write what velocity will be for this portion. Okay, so first calculate value of a from here. A will be equal to v square minus u square upon 2l. We have to write for L by 2. After travelling a distance L by 2, what will be the velocity? Let that be v dash. So v dash square can be written as u square plus 2a. In place of L, now we have to write L by 2. Substitute value of a from above, that is u square plus 2 v square minus u square upon 2l. This multiplied with L. These two got cancelled. To solve it, you will get v square plus u square upon 2. This is the velocity with which middle part of train will cross the point O. In next session, we will study one-dimensional motion, but that has to be along the vertical. It has some specific criteria, because in vertical direction, as we all know, that acceleration is equal to acceleration due to gravity. Let us see. Here the motion is uniformly accelerated, and that acceleration is in vertical direction. Its value being fixed, that is equal to acceleration due to gravity. So this is the thing which separates it from other kinds of one-dimensional motion. Here motion is along a vertical line, so only acceleration due to gravity is effective in this direction. Now let us see some sign convention which will be needed while dealing with all the numericals come under this topic. So what is the sign convention used? Generally students get confused when writing plus and minus sign for this kind of motion. Students generally assume that for upward motion and for downward motion, sign convention has to be separate. No, it is not the case. Sign convention should be according to your convenience. If you are taking upward direction as positive, then whatever kinematical quantity is in upward direction, that has to be taken as positive, whereas downward as negative. And this is true for all types of motion, whether it is upward motion or the downward motion or the opposite. You can conveniently consider downward as positive, then of course upward would be negative. So this sign convention has to be according to your convenience. Now we will move to some illustration so that this sign convention can be applied, and then it will be crystal clear to you. But before moving to that, let us see some graphical presentation of this kind of motion. Here it is saying draw graphs for all the kinematical terms. Now what are the kinematical terms involved in the motion? That has to be displacement, velocity and acceleration. For a freely falling body which is colliding elastically with ground and caught after two bounces. Okay, so we have to draw graphs of all kinematical terms up to two bounces. So let us consider that it is the freely falling body. What does it mean by a freely falling body? Its initial velocity has to be 0 because it is being dropped. So initial velocity will be 0. It is being dropped. First it will come to the ground, collide with ground, and it is saying that it is colliding elastically. So it will collide with ground and then move up. If it is elastic collision, of course will go up to the same height, then will come again down, collide again. So we have to draw the graph for two bounces. Let us start now. First I am drawing for the displacement curve. As already I have said that on x-axis generally we consider time, and since we are writing displacement here, so on y-axis this is displacement. Now we have to start with t is equal to 0 when the ball was being dropped. So when it had been dropped, what was its displacement? For this we need a reference line from which displacement has to be measured. So let us take the ground as reference position. If this is the reference position and initially the ball was at height h, so what is its position at t is equal to 0? That is h. From height h it started falling. Now it will come down to ground, so this will reduce to 0. After some time, whatever be the time taken for coming it to ground, after that time its displacement will be equal to 0. Let us first calculate this time. So time taken will be, let that time be t1. So t1 will be equal to root under 2h by g. This t1 is equal to root under 2h by g. It is time taken before first collision, and you can see from here displacement should come to 0. But in which manner? Should it be a straight line or any other manner? No, it cannot be a straight line because it is a constant acceleration motion, and as we all know, if acceleration is constant, velocity time graph will be linear, displacement time graph will be parabola. So it will be parabolically reducing to 0. So till first bounce we have drawn the graph. Now it will go again up to the maximum height, will come down again. This is second collision, and then of course caught. What will be time between these two? When it is moving up and then coming again, let this time be t2. t2 is the time at which collision is taking place after the start. So t2 will be equal to, now t2 we can calculate here, that will be equal to, so this value will be 3 times root 2h by g. Here it is elastic collision, so it will take time t1 first to come to ground, again will take the same time t1 to go to maximum height, and then will take again the same time to come again to ground. So the total time till second collision will be equal to 3 times root under 2h by g. So this is displacement time graph. Now let us move to velocity time graph. For velocity time graph, on x-axis we are taking time, on y-axis it's velocity. Now we have to choose the sign convention. Sign convention, as I have chosen, is upward direction is taken as positive. It will start with 0 velocity because the ball is being dropped. So initial velocity has to be 0. So starting from here, now in which manner will velocity change? It has to be along a straight line because acceleration is constant. So velocity has to be a straight line. And its direction, because it is being dropped, so direction has to be downward, which we are taking here as negative direction. It will go on increasing in negative direction, will come to its maximum value when it strikes the ground. At this moment itself, its velocity will get reversed because it is changing its direction. So at this moment itself, velocity got reversed and has come to the same value but in positive direction. From here again it will go on decreasing because now the ball is moving in upward direction, so its velocity will keep on decreasing till it comes to the maximum height and gets stopped. After that will continue moving in downward direction. So the same kind of graph here again will get reversed when it has collided with the ground. Velocity will get reversed and this will so on. So this is how velocity time graph can be drawn. Now let us come to acceleration time graph. This is acceleration time graph. Is acceleration changing during the motion of this ball? No, its value is constant, that is equal to acceleration due to gravity g, but its direction is negative. So here we have to draw in negative, its magnitude being 9.8 meter per second square, and in negative, so a minus sign is here. This value will continue till the collision is taking place, because at the moment of collision the ball is colliding with the ground. For that moment its velocity is getting reversed, so there must be some impulsive force on the ball which will change its direction for that particular moment when ball is being in contact with the ground. So for that moment only its acceleration will be positive and will be having a very high value only for that moment of time for which ball is in contact with the ground. Then this will continue again till second collision. For second collision, for the time of second collision, again its value will go shoot on in positive sense, and this thing will continue for all number of collision. So this is how acceleration time graph can be drawn. I hope you understood all the graphs clearly. I have taken one illustration here. A €1 coin is dropped from the Leaning Tower of Pisa. It starts from rest and falls freely. Falls freely is, it is starting with initial velocity 0. Compute its position and velocity immediately after 1 second, 2 seconds and 3 seconds from the instant of being dropped. Okay, let us start now. Since it is being dropped, so initial velocity has to be 0. It is asking for its position and velocity after 1 second, 2 seconds and 3 seconds. So let us first calculate its position. So if you take the initial position as y is equal to 0, and then this being y1 after 1 second, y2 after 2 seconds and y3 after 3 seconds, right? Now whether these will be same or different, this we will see later on. Let us first calculate the values. Here I am taking downward direction as positive because this is convenient. All the kinematical terms here are in negative direction. G also is in negative direction, displacement also is in negative direction. So I am taking downward direction. So let us write now position y1, that will be equal to ut plus half at square. I am writing that will be half because initial velocity is 0. So half g t1 square, which is equal to 1 square. This will become g by 2. Next is y2, that is half g into 2 square, that is equal to 4g by 2. The third one y3, half g into 3 square, which is 9g/2. So these are the positions after 1 second, 2 second and 3 second respectively. Let us now compute its velocity after 1 second, 2 second and 3 second. So v1, if we write as velocity after 1 second, that will be, u is taking 0, so it will be g into t, g into 1, that is equal to g, v2, g into 2, so it is 2g, v3, 3g. Do remember, here I have taken downward direction as positive, so all the terms are coming as positive. Got it? So there should be no confusion for sign convention. According to your convenience, you can take one direction as positive and then opposite will be negative. One more illustration is there. A stone is thrown vertically upward. On its way, it passes point A with speed v and passes point B 30 meter higher than A. Okay, so let us draw this situation first. A, it is passing with v, and B, which is 30 meter higher. So this is B, distance between A and B being 30 meter. At point B, its speed is v/2. Find the speed v, the maximum height reached by the stone above B. These two things are to be calculated. Let it comes at some height h above B. So we have to calculate its speed and the maximum height reached by the stone, that is h. Again we have to choose sign convention here. So this time I am taking upward direction as positive. Let us start with first part. The speed v first we have to calculate. Okay, I am writing equation between the points A and B, A being the initial point and B being the final point. So I can write final velocity, that is v square by 4, is equal to initial velocity, which is v square minus 2g, and distance between these two is 30, or it can be solved, v square into 3/4 is equal to 2g is 10 into 30, that is 600. So from here we can write v is equal to 2400 upon 3 and square root of this, that is root under 800. Nearly it will come as 28 meter per second. So this is the speed v which we had to calculate. The second thing is maximum height reached by the stone. Okay, so at maximum height its velocity will be 0. So we can write at maximum height velocity is 0, and initial I am taking at B for this part of journey. So initial velocity will be v square by 4 minus 2gh. From here h we can get as v square upon 8g. Now if you substitute the value, v square we had got 800 upon 8g, that is 80. So this value comes out to be 10 meter. The maximum height attained above B is 10 meter. We will do some more numericals in our session after this chapter is completed, and we will see a lot number of questions from previous year examinations as well, right? Okay, bye.